Is there any questions with you? Anyone can ask a question?
Yes, sir.
Yeah, please. Thank you, Dr.
Professor, I have one question. Actually, I want to apply reinforcement learning on the drone. So, actually, I am working on that. So I need some guidance on that. first thing is that, and second thing is, you showed some reconfigurable means reconfigurable
Reconfigurable bags.
Yes, yes. Flying.
Okay. What's slide?
Just the back side.
This one.
This one.
Okay.
So, which kind of materials it is made up of?
This hub.
Yes. I have.
Our prototype we made by 3D printer. It means that it made of plastic.
It may be plastic, but Professor, can we use the shape memory alike for this? It may be a potential solution for that, because if it is get distorted and by applying only the voltage, it can regain its shape. So it may be SMA can be a solution for that. Maybe, I am not sure.
Can you explain more detail about this?
Actually, shape memory alloys are those materials which get, if it gets deformed, and once we apply some voltage or current on that, it gets its initial position, means it goes to its initial position.
Okay.
So once it strike collide with some flying object, it may be distorted, but after applying some voltage, it can get its shape.
Thank you so much for this idea. Let me. I don't have the right answer for that, but let me share my experience for that. Okay. You know, the propeller is a rotation part, but the hub is a static part. So when a rotate part is working on static part, it means that the contact changes every time. That raises a problem. If you want to apply a voltage, it always need contact. And when you move too fast, it's still like an electric motor, right? So it will be the friction between that will reduce the stability of this idea. We have tried this to measure the coordinate fork. We tried to measure the coordinate fork by using some straight gauge, but after a few times of working, this cannot work as I want.
Okay. And one more thing, Professor, my friend is working on this these drones to get stability on working on at Bristol Robotics,
Sure.
University of Bristol. So maybe we'll have some collaboration with that. So
Thank you.
Thank you, Dr. Vishnath, for the query. Any other query? Hello? Hello?
Yeah.
So,
You can directly ask. Thank you, sir.
I think your presentation is very interesting, but in this study you just concerned to the safety of the UAV. So I think the limitation will be happen with the energy of the system. For example, if you have the hub airflow, you can easily fly from the A port to B port very easy. But in your case, maybe you need more energy to fly with the same trajectory.
Okay. Thank you so much. It's still like a deep, high-level question. So I would like to share it, if you don't mind. Just okay. I will talk short about this. Yes. In my research, I have tried to modeling this deformable propeller and try to answer how about the energy consumption about that. And I have the modeling and I have a practical data. So I found that mostly the energy consumption is almost the same. Almost the same. That is quite incredible, right? Yeah, it's quite incredible. But yeah, exactly based on my modeling. But it, as you mentioned, it's really hard. It really hard to control especially when we change the velocity suddenly. So with the deform, it will be deformed and it will be flapping. It's really hard, but only a about the energy consumption. It's almost the same. Almost the same.
Improved by simulation only.
Simulation and real practical. By practical data. Yes.
About the
Yes. We test that. We test that. We simulate that. So that's okay. In detail, this research has been published on Gachibowli introduction on robotics. So.
Hello. Thank you, Dr. And any other question? Okay, fine. I have the last question.
Sure.
Though it's not direct connected, but it's indirect connected. Nowadays, the drones are increasing day by day in number of activities or functions. Have you seen any disasters in drone? Like you see the birds, or you have shown some example of the picture of different type of animals. So while they are so more, so they're fighting together and then some getting down, say die or say maybe injured. So have you seen any disasters on drone? Like you say hundreds of drones are that they hit it.
Just
A failure of software. My question is not hardware. My question is failure of software or non-proper automation of software. Into that, have you any experience?
Which is idea? Yes. It's very interesting question. Yeah, you know, because we talk about the safety of the drone, right?
Yes.
And so when the drone work in a swamp, it means a lot of drone working, like this. It's called the collision. It's easy to be happen. That's why we in Japan there are a company named the Drone Soul Company have contacted us. They want to apply this idea into drone, and they want to reduce the number of the following drone, because based on the Japan rules, there are only under 1% of drone can be full in a drone show. While in China, it's under 10%. So that in Japan is really tricky.
Yes.
So the only thing I can tell you, because it's a commercial contract, that we have applied this idea into the drone show, and now it can still fly. But until now, I don't have a real video of how it works with a swarm. But we apply this, we change the design of the drone.
Have you ever encountered something like that? That's hitting, some mismatches happening, something really in the real time. Say 4 drugs you are trying together, some hits or something like mismanagement.
You mean that the real photo of this one?
Not just you encounter sometime in your life. I have seen, I tell you, see, recently like in Republic Day, we are using around 400 plus drones together to create a picture of our country.
No.
So while the trial, we have seen some drones are ineffective, though maximums are going on and at the end they are picturing, but few are again not. So when we come into the conclusion of performance, we are still working. So many papers I have read. So just I'm thinking and asking, like, do you think towards that area into this? Think on to that, because safety, when we are looking, so safety is not only for drone, it is for us also.
Yeah. That's why I give these photos on the last.
Now the drones are maximum using for many activity. Even
That's why
drones is very common nowadays.
That's why I saw this photo, this picture in
Yes.
my last.
That too is collision, so it's very common and futuristic research problem also. Yes.
This bio-instructional idea can be applied into many kind of field, such as grass cutting machine, or for the windmills, or for the how can I say underwater vehicle, something like this. It's mostly focused on some rotation part, which can challenge human life.
Okay. Thank you for the interesting lecture. Thank you.
Yeah, more questions.
More questions.
More questions, that's great. No, please ask me. No,
Please.
He's very happy and enthusiastic to reply. Please sit. Give no problem.
I own everyone an upload guy, so please ask questions.
Yes, thank you very much. It's enthusiastic, let it reply. Yes,
Sir,
ma'am.
how is limited endurance being handled in your areas? Because most of the drones are working, and in case if it comes against battery down issues, limited endurance being handled in UAVs.
So So I understand you want to ask about my limitation of research. Yes, and why it's not plastic.
Unnecessary you are worried that we are getting there. The people so excited.
You mean the real problem? Okay, let me tell you. The first problem is beyond my limitation. I have told you about the complexity of problem. So it means that it almost the formable problem is almost the same, not almost the same. So when you work the general form between each rotor is sometimes it's almost balanced. So we need an adaptive controller. I mean that we need another controller to balance this drone. So in the first problem, it's not still good and balanced. And the second problem that when you suddenly change the velocity of this drone, it means that you suddenly change the thrust fork of this propeller. It can make the flow of the propeller deform and it can become flapping. So it's really hard to control this situation. So now there are some practical problems almost beyond the physical structure of this propeller.
Thank you, sir. Thank you very much.
Dr. Sen, please take the chair. This for forever.
You're welcome.